So this is the first stuff that you're going to learn that I expect you to know for a test or a quiz, what you need to know for the course. We're going to talk about scientific notation, but first, physics, you're going to find we're going to use models, often mathematical, to help us understand how the universe works or a particular set of phenomena. But I have to emphasize from the very beginning, almost everything that I teach you this year will be wrong. We're going to ignore air resistance because that makes the math yucky, or we're going to ignore friction, or we're going to assume that an object is sitting exactly on the ground when actually it's a little bit above the ground. But we'll be close. We'll have good approximations, but full disclosure, everything that I'm teaching you this year is technically wrong, but it's also mostly right, which sounds kind of weird for a science course, but you'll figure out as we go along where we're making exceptions. Since our models are mostly mathematical, good math skills are helpful. However, I also believe that taking a physics course helps you become way, way better at math. So if you're someone who's a little shaky mathematically, you, by the end of this semester, will be far better than you thought. Trust me. One skill is what we call scientific notation. What's scientific notation? It's how we can write really big and really small numbers. Numbers that we can't fit on our calculators because our calculators can typically only handle about 8 or 9 digits. We can't pick and choose the numbers that the universe gives us. You got to go with it. So what are the rules for scientific notation? First of all, there can be only one digit to the left of a decimal. So 12.3 times 10 to the fourth is or isn't in scientific notation. Let's vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Duke will make fun of me if I don't vote, and Mr. Duke will make fun of you if you don't vote. Okay? So 12.3 times 10 to the fourth. Who says, oh yeah, that is in scientific notation. It's got a 10 to the. 1, 2, 3, 4, 5, 6, 7. Who says, no, it's not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I like Hannah. Hannah did the peer pressure. I'll adjust my hair and they'll think maybe I'm voting that way, but no one will know. That was very smooth. I saw that. What did I say? I think 16, something like that. Convince me. Who's correct? Convince me. Is or isn't? Yeah. What are you defending?
That it isn't?
Why?
Because there's more than one decimal.
Yeah, look, can't have more than one number to the left of the decimal point. This is not in scientific notation. How would I write that in scientific notation? 1.23 times 10 to the... I can't be 4. Can't be this. I can't move the decimal and still have the 10 to the be the same. I think 5, I bumped it over by 1. Now, I'm already sensing some of you haven't seen much of this. Don't worry. Step 1, rule 1, only one number to the left, one digit to the left of the decimal. Rule 2, you count the number of places the decimal point moves. If the decimal point moves to the left, that's that way, for those who haven't figured that out yet, the power of 10 will be positive. Stop, look up, stop, don't write. I told you I tend to abbreviate. This is my abbreviation for the word positive, a plus sign with a VE. That's the word positive. If I just see a plus sign, I assume that's part of an equation and I go looking for the rest of the equation. So if I want to use the word positive, plus sign VE. If the decimal point moves to the right, that way, the power of 10 will be, anyone? Anyone want to guess how I abbreviate negative? very important that you learn how your calculator handles scientific notation. So I'm just going to make up a number. I'm going to write 164 and then 1, 2, 3, 4, 5 zeros. Write that down. Not on your calculator. Write that down. You have to be able to go from, we call this standard form, to scientific notation in your head, in other words, without technology, but you also need to know how to do it with technology. I'm going to write this. Where will the decimal point end up? Right there. So it's going to be 1.64. I don't write the extra zeros. Times 10 to the. Where was the decimal point originally? Well, it's kind of assumed that it was there. So with your pencil, if you count, how many places did I move the decimal point? Yep.
7.
You sure? I'm just messing with you. Yes. By the way, I will mess with you. I will expect you to have confidence in an answer. So don't let me throw you off, okay? 164 with 5 zeros is 1.64 times 10 to the 7th. And that's how you would say it in English. If I have a really small number, 0.123456107, can you write down 0 point and then 6 zeros, 107? How would I write that in scientific notation? Good question. The decimal point is going to end up where? Well, right there, because you're only allowed to have one non-zero digit, one digit to the left of the decimal point. So Robbie, it's going to be 1.07 times 10 to the. Did we move the decimal to the left or to the right? We're writing a small number. I always put the negative so I don't forget, because I've lost track of how many times I've done everything right but forgotten the negative. Never happens. And I'm going to do the same trick. I'm going to count. How many places did I move it? The most common mistake, kids want to say 9 because they want to go all the way to the end. No. After the first non-zero digit. Let's try some on the next page. It says, rewrite the following in scientific notation. This is why we have to have it. The Earth weighs that much. That's the mass of the Earth in kilograms. Can you fit that into your calculator? No. I can because I have a graphing calculator, but even so, I want to abbreviate. And scientific notation is a great abbreviate. So, how would I write this in scientific notation? It's a good question. Where's the decimal going to end up? Between which two digits? The 5 and the 9. So it's going to be 5.98 times 10 to the 24. Is she right? It's Mesa. I don't know. She's missing a shoe. Is it 24? Now, I might go 3, 6, 9, 12, 15, 18, 21, 20. This one is nice, and I think amazingly Mesa is right. This is still wrong. One thing I am fussy on, your final answer, this is our final answer, got to have the units. I don't make you show units during your work. In fact, I won't show units during my work because I'm lazy. Final answer page better have units. So what are the correct units here? Kilograms. Mr. Duick? Yeah? How do we know that's the mass of the Earth? It's not like we put it on a scale. If you take Physics 12, I'll show you how we figured it out. One proton has a charge of that many coulombs. Okay. I can't type that into my calculator. Where is the decimal going to go? Between which two numbers? 1.6 times 10 to the, it's a small number, so negative. What? You're correct. In fact, we call that number there has a special name. It's called the elementary charge, because that's the charge of a proton. It's also the charge of an electron. It's just an electron is negative 1.6 times 10 to the negative 19. So it's a fundamental charge of the universe. It's if a penny is the fundamental unit of money in our system, that is the fundamental charge in the universe's charge system. That's the universe's penny. Can't get smaller charge than that. Sorry, I lied. I told you most of what I'm going to teach you was wrong. You can't get smaller charge than that until you suddenly realize that there are things called quarks and run them through particle accelerators. So you can get smaller charge than that, but we only figured that out about 80 years ago. The temperature of the sun is 15 million degrees Kelvin. What? Kelvin. Okay. I think before I go to scientific notation, I need to write this in standard form. So 15 million. Is that million? That? Oh, have I gone too far? There? Okay. 1.5 times 10 to the 6th, obviously, yes? No, with the 6 zeros. You're not counting zeros, you're counting how many spots you've moved the decimal point. And for really complicated ones, don't be scared to draw the loops and just count. So here's what I would do for a complicated one, or even on a test for an easy one. I would murmur to myself, 1, 2, 3, 4, 5, 6, 7 degrees K. So step one, you need to be able to go from standard form to scientific notation. Step two, you need to be able to reverse it. You need to be able to go from scientific notation to standard form. So 5.4 times 10 to the negative 7, rewrite that in standard form. Is that a really big number or a really small number? How do you know? What's negative? Okay, the exponent, because I could have a negative in front. That doesn't make it a small number. Okay. So 0 point. What's the exponent? How many zeros am I going to write? 6, which is a little tricky. 1, 2, 3, 4, 5, 6, 5, 4 meters. 4.23 times 10 to the third joules. Okay. Is that a bigger number or a smaller number? Okay, so no 0 point. I guess I'm going to go 4, 2, 3, and then 3 zeros. No? Why? How do you get that? Okay, the 2 and the 3 count as the first spot. There's the third spot. There's the 10 to the 3. Units, joules. I got to be honest, by the way, I would never write this in scientific notation in the first place. To me, scientific notation exists as a shortcut. And so, Nicole, I always ask myself, literally, what's less characters to write? I'll write it that way, unless the instructions specifically say different. But if you're asking me, Mr. Dewick, what's your rule? When do you want it in scientific notation? Whatever's laziest. Unless the instructions say different. So the fact that this said, if they had given me this and they had said, write it in scientific notation, I'd write it, but I'd also be going, why? Give me 1 second. Let me hit pause. Okay. Hey, what's capital G, capital W? What's the capital G? Giga.
Gigawatts.
Gigawatts, not gigawatts. Back to the Future got it wrong, and it drives me crazy. It's gigawatts. All right. Big number or small number? Okay, what am I going to write? I guess 4.06, because I got to carry all the stuff after the first digit, times 10 to the negative. Yeah. You said 9. I said ja. You said 9. I said ja. Sprechen Deutsch ein bisschen? 9. Ja. You just figured that? Okay. 1, 2, 3, 4, 5, 6. Ooh, I don't know. Is it 9? 1, 2, 3, 4, 5, 6, 7. So I actually say to you, 9! 8. Oh, I totally believe you. Higher. What's that funky... Oh, what's mu and a G? Micrograms. Yeah, those are micrograms. Okay. By the way, they used to be called microcomputers. Now they don't even say that anymore, but they were called microcomputers because that's when chips were the size of a micrometer or a micrometer. It's often how they pronounced it. But that's where the term microcomputer came from, when chips became that small. Now they got chips that are the nano size, so they're pretty impressive. 4.2 times 10 to the 6, you say? Yeah, this I would probably write in scientific notation because that's less writing than that. This I would definitely write in scientific notation, way less writing than that. I would leave this as 4,230 unless they made me. Now, each of your calculators has a way to enter this in scientific notation. So here's what I would like you to do. Look at your calculator, and you're looking for one of the following buttons. If you have a TI, you're looking for an EE button. It's probably a shift right above the 7. If you have a Casio, you're either looking for a times 10 to the and a little box, or you might be looking for an EXP button. That is your scientific notation button. If I want to type 6.23 times 10 to the negative 5 into my calculator properly so that things won't go wrong later, this is what you're going to type. Everybody pick up your pencil. Write a 6 and put a box around it. All of you will hit a 6 on your calculator. Write a decimal and put a box around it. All of you will hit a decimal point on your calculator. Write a 2 and put a box around it. You'll hit that. Write a 3 and put a box around it. But here's what you will not hit. You don't need to hit a times. You don't need to type a 10. You don't need to hit a to the power of. Your scientific notation button has all of that built in. So the next button you're going to hit is whatever your scientific notation button is. And then you're going to hit the negative sign and the 5. If you're not sure where your scientific notation button is, now is the time to raise your hand. Why am I being so fussy? It's far less work to find your scientific notation button and hit it than it is to type times, 1, 0, exponent, and then. But secondly, your calculator is actually smart. If you hit this button, it knows that the 6.23 is attached to the times 10 to the negative 5. And so you can get away with typing a lot fewer brackets and things because it knows they're attached. Okay? If you hit enter to store it, some of you may have noticed that your calculator, instead of displaying times 10 to the, does a capital E or a really small EE. That's because computers used to do it that way. And a lot of your calculators are using a modified computer OS. That's why what I was saying to one of you, can't use a negative and a subtraction interchangeably. They're not the same thing. So if you hit equals, you would have stored it in your calculator. Yes? Some of your calculators would have just parroted it right back to you. Some of your calculators would have showed you this. One of your calculators, I think, did this. And you had to use your, this is why I hate that one, because you have to use your imagination and realize all that's there. It's not 6.23 to the negative 5 power. There's an invisible times 10 to the, with that space. Ugh. Some of your calculators might have done this. Because you can toggle or tell your calculator how many decimals do you want me to show before I automatically switch to scientific notation. And we'll dive into some of those settings if you wish. But for now, you were all able to type it in, turn the page. We're going to perform a calculation on our calculator. Stop. I'm going to be really fussy. I'm going to show you the minimum number of keystrokes for the maximum organization and the minimum confusion, because most of you have not been taught that handwriting is different from on your calculator. Specifically, on our calculator, we'll use as few brackets as possible because brackets are tough to figure out on our calculator. Handwriting, we use brackets. On our calculator, we don't. So you ready? Raphael, not working ahead yet? Here we go. First of all, is this a fraction? Everybody say yes.
Yes.
Yes? Okay. Is there more than one thing on the top?
Yes.
So everybody's going to open up a bracket. Open a bracket. And this is where those of you whose calculators I've criticized are going to start to realize, holy smokes, my neighbor can see everything and I'm having to track everything up here and it's driving me cray-cray. 1.8, type that. Am I going to hit times 10? No. Now, after the 8, I'm going to hit my scientific notation button. Mine looks like that. Hit whatever your scientific notation button is. What's the exponent on the 10? So, negative, whoop, wrong button. Negative button 3. Stop. I'm not going to close off the bracket. If I do that, I've just told my calculator that the top of the fraction ended there. Has the top of the fraction ended? No. What do two brackets side by side mean mathematically? Hit a times button. It's less typing and it's way easier to track because you got fewer brackets cluttering up your screen. I will never show multiplication with two side by side brackets. I will always just use a times button on my calculator. 2.6. Now what? Scientific notation button. Have we reached the end of the top? Close off the top. The cheaper calculators, yours probably, when you closed off the bracket, it probably calculated the top and changed the number, scaring you. I don't know what it looks like. Don't panic. What does a fraction mean as a mathematical operation? Divided by. Is there more than one thing on the bottom? Well, brackets are on the bottom. Open up a bracket. 9, yeah. Scientific notation button. 8. Am I going to close off the bracket? No, because then I'd be telling the calculator the bottom ended there. It does not. Instead, what do two brackets side by side mean? 1.3. Scientific notation button. -1. Close off the bottom. I think that's way easy. Look what I've typed. I can see what's on the top. Yes? I can see what's on the bottom. Hit enter. Equals. I get 4 times 10 to the -6. Some of yours might say 0.0000004 because your calculator might be programmed to show 7 decimal places before it defaults to scientific notation. If yours has a fraction, then right above your, I think right above the number 9, you have either an SD button or a change button. Press that, and then press it again, and then press it again. And that will cycle between fraction answer, decimal answer, fraction answer, decimal answer. Okay? So in math, we typically go with fraction answers. In physics, you'll want the decimal answer, Gabber. Okay? Sorry? We can. There's all sorts of settings you can toggle. Yes?
I got 117.
And that's because you made a typo. We'll look at it in a second, but that's because you've got a much tougher calculator to track everything on. I told you on the first day, it's worth getting a good calculator. I'm going to write 4 times 10 to the negative 6, because that's less work than writing 0.00004. But you can write either, because the question didn't say. Tyson, did you get the right answer on yours or not? Yeah. Later on, I'll sit with you both. We'll try it, and I'll show you how to do it properly. But for now, let's try one more. Oh, too far. So, is this a fraction? Yes. Pause. Look up. Some of you have this button. If you have that button, hit it. And you can actually do a fraction with a top and a bottom. And so all this bracket crap that I'm saying to you, you get to skip because you spent about $3 extra. The rest of us that don't have this fancy schmancy 2-level fraction button, we have to do it like this. Is this a fraction? Is there more than one thing on the top? Well then, Cam, I'm going to open up a bracket. Then I'm going to go 5.8. Am I going to hit times or 10 or to the power of? Scientific notation button takes care of all that for me. 3. Am I going to close off the bracket? No. Times 2.67. Scientific notation button, 21. Have I reached the end of the top? Now I'll close off the top. Those of you with the fraction button, you can just go down arrow, and now you're in the basement of your fraction. Isn't that nice? Me, I got to go divided by and open up a bracket. Negative, not subtraction. 9.24, scientific notation button. Negative 3. Ooh, all of that to the 5th power. Now you'll notice when I typed it, I put this in brackets. But if I've used my scientific notation button, my calculator knows that that E negative 3 is attached to the negative 9.24, that they're all one number. So I can get away, probably, without putting that in brackets, unless you have a cheaper calculator. You might need to. We're going to find out. But I need to do an exponent. The power of, for most of you, it's that little symbol right there. It's a shift 6 on a keyboard. The carré, the thing that looks like a little hat. Most of you, it looks like that. Some of you, it might be a button that says that. Or it might be a button that says that. You need to find your exponent to the power of button. It's not EXP, that's scientific notation. If you can't find your exponent button, I will come. So for me, as I'm typing to the power of 5, there's 2 brackets. What do 2 brackets side by side mean? You might be able to get away without hitting times. I think you'll have to hit a times there. So if you got an error, that would be one of the first places I would check. 1.3, scientific notation button, negative 1, close off the bottom. If you've done it right, you're going to get negative 1.76862617 times 10 to the 36th power. If you did not get that, now is your chance. Don't clear your screen to call me, and I can usually figure out where you might have zigged. So I got negative 1.768626. Mr. Dewick, what do you want me to round off to? Tomorrow, Monday, the lesson is going to be on the science rules for rounding off. It's called significant figures. You'll also be seeing a similar lesson in Chem 11 if you're in Chem 11 this semester in the next day or two, or you might see it today, because I know Mr. Perugia and I, it's one of the first lessons that we do. So for now, I'll round off to the third digit, which is the second decimal place. I'll write negative 1.77 times 10 to the positive 36 or negative 36? Which one was it? Are you positive? And then what I'll do in my notes, I'll paste what I typed in my calculator. Yeah, I can do that. It says homework sheet, blah, blah, blah. You can cross that out. I didn't bother photocopying the sheet. But on the next page, there's some homework for you to practice. These are all in scientific note. You have to give your final answers in scientific notation. And if you look at the very, very end, I did attach the answers. Please check your answers, because it's possible to do this totally wrong and have no way of knowing. My calculator says that's right. Yeah, but you might have made a typo, right? So if you get that done today in class, this will be your first assignment that's quote unquote due on Monday. Put your pencils down and look up.